Okay. Cinco de Mayo. Here we go. 1 through 8. Evaluate the integral. 0 to 1. 5 dx. See ya. 5x. 0 to 1. 5. If you have questions, let me know. Number 2. 0 to 1. X squared. X cubed over 3. 1/3. 3. Natural log 2, natural log 3, e to the x, integral of which is e to the x, e to the natural log of 3 minus e to the natural log of 2. E to the natural log of 3 is 3, e to the natural log of 2 is 2, 3 minus 2 is 1. 4. Cosine, 0 to pi over 2. Cosine. Can I, does this work if I do it this way? Yes. Oh, that's much better. Integral of cosine is sine. 0 to pi over 2. Sine of pi over 2 is 1. Sine of 0 is 0. 0 to 1/2. 1 over the square root of 1 minus x squared. That's an inverse sine, arc sine. 0 to 1/2. The arc sine of 1/2, that's the angle whose sine is 1/2. That's pi over 6. The angle whose sine is 0 is 0. Okay. 6. From 0 to 4. Square root of 2x plus 1. This is a u to the n form. U is equal to 2x plus 1. The du is 2 dx. Multiplied by 2, multiplied by 1/2. It's u to the 1/2, so the integral of u to the 1/2 is u to the 3/2 divided by 3/2, which is multiplied by 2/3. Okay? Are we okay with this? I'm multiplying by 2 and by 1/2 to get my du. This is where the 1/2 comes in. These cancel. I have 1/3. Put the 4 in. 2 times 4 is 8, plus 1 is 9 to the 3/2 is 27. 0 plus 1 is 1. 26/3. Okay? 26/3. Everybody okay with this? Okay. Okay. Robbie, you okay with that? Okay. 7. 1 to 2. 1 over x dx. That's a natural log, absolute value of x. That's natural log of 2 minus the natural log of 1, which is the natural log of 2. Because the natural log of 1 is 0. Okay. Everybody okay?
Wait, what was the answer?
What? All right, hold on.
Oh, 7. Okay. Yeah, never mind. I got it right.
You got it? You have it?
No. It'll take me a second to use that paper.
Can you use it?
I can read it.
8. The integral from 0 to pi over 4. Secant squared. Integral of secant squared is tangent. Tangent of pi over 4 is 1. 9. Radioactive iodine decreasing exponentially. Damn it!
Hey, can I grab the video after?
Yes,
Give me a call.
I'll give you a call. It'll be in about 10 minutes.
All right, I'll come back down like that.
Okay. So whoever was asking me if I'm getting the video up there, I guess we will. Radioactive iodine is decreasing exponentially at a rate of 5% per century if the initial amount is 100 grams. So you have a radioactive decay problem. Okay. Q sub naught is 100 and K is a 5%. So that's how much radioactive iodine is present at any time t. We want to find the half-life. We want to find the time it takes Q to go from 100, the initial amount, to 50. 50 divided by 100 is 1/2. You want to solve for t, take the natural log of each side. Natural log of e to that exponent is that exponent. And you want to solve for t. Well, you end up with natural log of 1/2 over negative 0.05. And that's just plain bad form. You should realize, of course, natural log of 1/2 is a negative natural log of 2, because it's the natural log of 1 minus the natural log of 2. Natural log of 1 is 0. Or the natural log of 1/2 is the natural log of 2 to the negative first power, and the negative 1 comes out front. This is a negative 1/20th. The negatives cancel and you get 20 natural log 2. Is that okay? Edwin, that's okay? You got that right? Nice. Nice. Okay? All righty. I'm going on. I can see some people don't like that one. There's a little algebra in there and stuff. Number 10. All right, that was number 10. Number 11. All right, given the area defined by the functions x squared, 0 to 2, 0 on the y's, that's the x-axis. X equals 2, that's the vertical line. Set up the integral that gives the volume. Okay, so we have y equals x squared. And we're going out to 2. Okay. All right. First one is about the x-axis. If you take this rectangle around the x-axis, you're going to get a disk. The volume is going to be pi. R squared. R is this distance. It's x squared squared. So it's x to the 4th. 12. If revolve around the y-axis, if you're going to go this way with it, where your rectangle is parallel to the axis of symmetry, that's going to develop, that's going to give you a cylindrical shell. This is R, this would be H. So the volume would be 2 pi RH. The distance from the y-axis is x. The height here is y, which is x squared. So you get 2 pi, 0 to 2, x cubed dx. 13, if you revolve it around the line y equals negative 1. Okay. You take this rectangle around that, you're going to get a washer. I probably should not have tried to draw it, but anyhow, you're going to get a washer in there. The volume is going to be pi, 0 to 2, big R. Now, big R is the distance from here to here. That distance is equal to 1 plus that distance, which is x squared. So it's x squared plus 1 squared. That's big R. Minus little r, which is this distance here, 1. Okay? All right. 14 through 17. Everybody okay? What's wrong? Everybody okay here? Carolina, you okay?
Yeah, so that's B, right?
13 is B, yes. Okay. 14. Integrate the following. 0 to pi, 2 sine squared. Well, to integrate sine squared, you need a half angle substitution, so let's do it. 0 to pi, 2. What is sine squared equal to? It's 1/2 the quantity, 1 minus cosine 2x. 2 and the 1/2 cancel. Now you've got to integrate 1 minus cosine 2x. Okay? Well, the integral of 1 is easy enough. That's just x. This is a cosine u form. U is 2x. The du is 2dx. So you're going to have to multiply by 2 and by 1/2. The integral of cosine u is sine u. Okay? And you're going from 0 to pi. See ya. Okay. We okay with that? Now, pi, you get the sine of 2 pi is 0. Put a 0, you get 0, you get 0, you get 0, you get 14, the answer is pi, apparently. Okay. All right, 15. X e to the x. Integration by parts. U is x. The dv is e to the x dx. Du is dx. V is e to the x. So we get uv minus the integral of v du. The integral of e to the x is e to the x. 0 to 1. You put in a 1 here, you get e to the first, or e, minus e. Then you put in a 0, and it's minus. You get a 0, minus, minus, plus e to the 0, which is 1. 16, sine cubed. What the heck? Sine cubed. Well, with sines and cosines to odds, what you want to do is take one of them out. It leaves you sine squared. That sine squared you're going to convert to cosines. 1 minus cosine squared. Now, when you multiply this out, you're going to have the integral from 0 to pi, a sine x, minus a cosine squared sine x. Which is okay, because the integral of sine is a negative cosine. And this is a u to the n, where u is cosine, the du is a negative sine. So you multiply by negative here and make this plus. So you get plus u squared du. So it's u cubed over 3 from 0 to pi. Substitute in pi. Cosine of pi is negative 1, but you got to take the opposite of it. So that's 1. Cosine of pi is negative 1. Cubed is negative 1, so that's minus 1/3. Minus, minus, plus cosine of 0, which is 1, minus cosine of 0, which is 1 again, 1/3. You end up with 2 minus 2/3, which is 4/3. Oh boy, kind of a pain in the neck, some of these. Everybody okay? Okay, everybody okay? Karen, you okay?
Yeah, I got the same equation. I just didn't know why I didn't get the right answer. I was just looking.
Do you know why now you didn't get the right answer?
No, my work's too confusing to figure out why.
Okay. All right, then I won't even presume to take a look at it. All right, 17. 0 to pi over 4. Tan x secant squared. U is tan, du is secant squared. You get u du tangent squared over 2. 0 to pi over 4. Tangent pi over 4 is 1. Tangent of 0 is 0. 18. Appropriate trig substitution, x is tangent theta. 19. Sum of the constants. Okay, you get 1 over x minus 1, x minus 2. Oops. X minus 1, x minus 2. You solve for a by multiplying by x minus 1. Let x equal 1. 1 minus 2 is negative 1. Solve for b. Multiply by x minus 2. Let x equal 2. 2 minus 1 is 1. b is 1. The sum of the constants is equal to 0. 20. The sequence Okay, converges to 1. The limit here as n goes to infinity is 1. That's all you need for a sequence to converge is have a limit, and you do. 21. Find the sum. Which one?
20 to 20.
20. What about it?
What about it again?
Okay. Sequence converges to 1. Because when you take the limit as n goes to infinity of n over n plus 1, that limit is 1.
Okay, I got it.
Okay. This series is geometric. The sum is equal to a over 1 minus r. R is negative 1/2. A, 1 plus a half. That's 1 divided by 3 halves. That's 2/3. Okay, 22. That series n equals 1 to infinity, negative 1. It's alternating series. It's n cubed. The thing to do is look at its positive series. The positive series converges to p series where p is 3. Therefore, the alternating series converges absolutely. If the positive series converges, the alternating series converges absolutely. Okay? 23. The series. Two to the n over n cubed diverges because the exponential part, the numerator, increases a lot faster than the polynomial does. And you could prove that with a ratio test. Okay? 24, the radius of convergence. To find the radius of convergence, use the ratio test. We'll take the limit as n goes to infinity.
Brian, I have a question.
Yes, question.
So does it, from greatest to smallest, does it go factorials, exponentials, polynomials?
Yeah.
Yes. Yeah, n to the n would be first in that list. And then what did you say?
Factorials,
Yes.
and then exponentials
Yes.
and polynomials?
Yeah, and the one after that would be natural logs.
So is this one just not increasing fast enough?
What, 24?
23.
23 is the numerator is increasing faster than the denominator. These terms are not going to 0. Consequently, the series will diverge because it's exponential over polynomial.
Yeah, but if it was going fast enough, wouldn't it like converge?
If that 2 to the n were in the denominator, yes, but not because if it's in the numerator.
Okay.
If it's in the numerator, the numerator is increasing faster. The terms are not going to go to 0. If you had taken the reciprocal of this, yes, it would converge because the denominator is increasing much faster than the numerator.
Okay.
Okay? 24, you get x to the n over n cubed. And we want to find the x's that cause that to be less than 1. Okay, so x to the n plus 1, x to the n. You got an n plus 1 cubed that comes below. What the heck? All right, I messed this all up. X to the n here. X to the n plus 1. N plus 1 cubed. N cubed is up there. Sorry. Okay? Now what happens when you simplify this? You get a limit as n goes to infinity. Subtract the exponents, you get an x. And then over here you got n cubed over n plus 1 cubed. Well, n cubed over n plus 1 cubed, that limit as n goes to infinity is 1. Because the same degree ratio leading coefficients is 1. So you end up with the absolute value of x is less than 1, and that means the radius of convergence is 1. So 24r is equal to 1. Devin, I'm just about done. I'm on 25 right now.
I'll be back at 5.
Oh, man. Okay. Okay. And 25. The error when using the first three non-zero terms to estimate cosine of 1 is, well, the error is the fourth term. Cosine, if we're going to use cosine's an even function, so it's 1 minus x squared over 2, x to the fourth over 4 factorial, minus x to the sixth over 6 factorial. You're using the first three terms to estimate cosine of 1. Your error is the next term. So when x is equal to 1, your error is less than or equal to 1 over 6 factorial, and that's 1 over 720. Now, the test that you take on Monday will look very similar. The question will be a little bit different. Every question will be a little bit different. But the same kinds of questions, you know what I mean? Same basic setup. All right, so that's what you have. Okay, do homework. Wait, I'm missing a page. What? Where's my page go?
I got it.
Ah.
Can I just see my test scores again real quick? Because I didn't look at it, just so I have an idea.
Where is 95, 97, 90, 90. No, you got 97 half of it. Wait, is this wrong?
No. I just was trying to recall.
Your labs are not so hot.
Yeah, I
Your
know.
lab.
Well, that's,
Sure.
I'm going to end up using that.
All right.
So it is. Okay. That makes me feel better. Thank you.
I'll drop it down to 180. What's the area? No,
Are you doing
you're on.
C++?
Let's do the end.
My computer died, so I had to buy a new computer. Then my computer got a virus, and the factory reset it.